Welcome to all. In the previous classes, we have seen the meters which is used for measuring current, voltage and power. And we have seen the construction and working of those meters which is used for measuring current, voltage and power, which is nothing but ammeter, voltmeter and wattmeters. In this class, we are going to see energy meter, which is used to measure the total amount of energy consumed over a period of time. That is, the total amount of electricity that we have consumed for a period of time can be measured with the help of this energy meter. So, these energy meters are most commonly used in industrial and domestic applications for the measurement of electricity which we have consumed. Now, let us see the construction and working of single phase energy meter. Single phase energy meter. So, in this we are going to see the most commonly used induction type energy meter. So, this energy meter is used to measure the total energy consumed for a period of time. The total amount of electricity consumed for a period of time can be measured with the help of this single phase energy meter. So, it will be measured in terms of kilowatt hour. Now, let us see the principle of working of single phase energy meter. It works on the induction principle, which is when a conducting metal part is placed in a alternating magnetic field, the eddy currents are produced in the metal part by the alternating fluxes. So, it works on the principle of induction, which is when we place a conducting metal part in an alternating magnetic field, then because of that eddy current will be produced in that metal part by the alternating fluxes. So, this alternating fluxes and the eddy currents produced because of this alternating fluxes interact with each other and it produces the rotating torque, or we can call it as driving torque, which drives the moving system. This is the principle of single phase energy meter. Now, let us see the construction of single phase energy meter. So, here we are having two electromagnets . So, M-shaped electromagnet . It is fixed with the help of a spindle arrangement. Coil will be wound on this one electromagnet. This coil is called as, this magnet is called as shunt magnet. The coil is called as pressure coil. Represent the shunt magnet as M2. So, one end of the coil will be taken out and the other end will be taken out, and we are having another electromagnet. It is called as series magnet. series magnet is represented as M1. The coil will be wound on the series magnet and the coil will be connected to the line and the voltage will be connected across this. In between the shunt and the series magnet, you are having a aluminum disc Surrounding the aluminum disc, we are having a C-shaped magnet which is used for braking purpose. This is a permanent magnet. This is called as braking magnet. The coil on this current coil will be connected to the load and the supply. So this is called as current coil. The coil wound on the shunt magnet is called as pressure coil, and the coil wound on this series magnet is called as current coil, which will be connected to the load, and the pressure coil will be connected across the supply voltage, and there will be aluminum disc which is placed in the air gap between the shunt and the series magnet, and the C-shaped magnet called as braking magnet will be placed around this aluminum disc which is used to produce the braking torque. Now let us see the construction of the single phase energy meter. The first system is the driving system. As we have seen in the diagram, the driving system has two electromagnets whose core is made up of laminated iron sheets. So here one electromagnet is called as series magnet, which is represented as M1. So this series magnet will be made up of U-shaped iron laminations It's made up of iron laminations. So a coil wound on this iron laminations will be of few turns of very heavy gauge wire. Why we have used only a few turns of heavy gauge wire is it carries the load current, because this current coil will be connected in series with the load, carries the load current. So the coil wound on this series magnet is made up of few turns of very heavy gauge wire. So this series magnet and the coil wound on this series magnet carries the current proportional to the load current. So current proportional to load current flows through this series coil. So this coil wound on this series magnet is also called as current coil. Current coil. So this coil is connected to one of the line and in series with the load. And the second electromagnet is called as shunt magnet. It is represented by M2. It is made up of M-shaped iron laminations to form a core, and the coil wound on this iron core has large number of turns of fine wire which is wound on the middle limb. So this coil is called as pressure coil. Since this shunt magnet coil is connected across the supply voltage, the coil is called as pressure coil or voltage coil. So, this is connected across the supply mains. So, this carries current proportional to supply voltage V. The next system is the moving system. It has a light aluminum disc mounted in a light alloy shaft and this aluminum disc will be placed between the shunt and series magnets. So, it will be placed in the air gap between the shunt and the series magnet and it is supported by jewel bearings. And there will be a pinion arrangement which engages the shaft of the moving system with the counting mechanism. So, the moving system has a light aluminum disc which is placed between the shunt and the series magnet and supported by the jewel bearings, and there will be a pinion which engages the shaft of the moving system with the counting mechanism. So, unlike other measuring instrument, this moving system of energy meter does not has springs and controlling torque. There is no spring and no controlling torque in case of single phase energy meter. The next system is the braking system. So, for producing braking torque, a permanent magnet is also called as braking magnet is placed near the aluminum disc for braking mechanism. So, the braking torque is produced with the help of this braking magnet which is placed near the aluminum disc. So, this braking magnet is a permanent magnet, it produces its own field . The disc also moves in the field of this magnet. And the position of this braking magnet is also adjustable. So, we can adjust the position of this braking magnet in order to control the speed of rotation of the disc. The next one is the registering mechanism. So, this registering mechanism will continuously record the number of revolutions of the aluminum disc. So, it continuously records the number which is proportional to the revolution of the aluminum disc, and a train of gears will be attached to the spindle which drives the pointers connected to the spindle which rotates on the dial. So, with the help of the train of gears which is mounted on the spindle will continuously record the number of revolutions of the aluminum disc so that the pointer rotates on the dial and the reading can be recorded. Now, let us see the working of single phase energy meter. So, in single phase energy meter we have two coils, one is pressure coil and current coil, and the pressure coil will be mounted or wounded on the shunt magnet. The coil wound on the shunt magnet is called as pressure coil because it is connected across the supply voltage, and this pressure coil will carries the current proportional to the applied voltage. So, this is shunt magnet. How the shunt magnet is produced is it acts as an electromagnet because the pressure coil which is wounded on the iron laminations when excited with the supply voltage will get magnetized and acts as an electromagnet. So, that electromagnet is called as shunt magnet. It carries the current proportional to the supply voltage since the pressure coil is connected across the supply terminals. And we know that another magnet called series magnet, it is produced by wounding current coil on them. So, the current coil will carry the current proportional to the load current. So, when the input supply voltage is given to the pressure coil, the current I proportional to the voltage flows through the coil, which in turn produces the flux phi1. And because of the current in the current coil which is proportional to the load current, a flux called phi2 is produced in the series magnet. So, what happens now is a part of flux phi1 produced by the shunt magnet and series magnet will link with the disc which is placed in between these two magnets. We know that aluminum disc is placed between this series and shunt magnet. So, the part of the flux produced by this phi1 and phi2 links with the aluminum disc. Phi1 and phi2 links with the aluminum disc. So, what happens now this, because of the alternating fluxes produced by the shunt magnet and series magnet, there will be eddy current induced in this aluminum disc because of this fluxes phi1 and phi2. So, eddy current is induced in the disc because of these alternating fluxes phi1 and phi2. Now, the flux phi1 will interact with the eddy currents produced by phi2. So, eddy current produced by phi1 will interact with phi2 and the flux phi2 will interact with the eddy current produced by phi1. So, because of the interaction of two fluxes and the eddy currents, two eddy currents which is produced by phi1 and phi2, each part of the disc will experiences a force. Each part of disc experiences a force. So, that force is called as the rotating torque or driving torque. So, because of this rotating torque or driving torque, the disc will start rotating. So, this is the production of rotating torque. The rotating or the driving torque can be represented as Td. It will be proportional to the amount of power we have consumed, that is Vi cos phi in case of AC circuit. So, the deflection torque Td will be equal to Vi cos phi. Due to motoring action, the disc rotates and the deflection torque produced will be directly proportional to the power consumed. Next one is braking torque. So, the purpose of braking torque, which is represented as Tb, is to control the speed of rotation of the spring. Speed of rotation of the disc. The speed of rotation of the disc can be controlled with the help of this braking torque Tb. So, the speed of the disc is controlled with the help of a C-shaped magnet which is called as braking magnet. So this braking magnet will control the speed of the disc. How it controls the speed of the disc? We know that because of the deflection torque Td, the disc starts rotating. As the disc starts rotating, we know that the disc is placed in between the series and the shunt magnet, and also a C-shaped magnet will be placed across the disc. Now what happens is, when the disc rotates in the air gap between the braking magnets, eddy currents are induced in the disc because of this permanent magnet. We know that when a conductor cuts the flux, EMF will be induced in that conductor. And because of this EMF, what happens? Eddy current will flow in that conductor. Now what happens? Because of the deflection torque, the disc starts rotating. Also the disc, which is a conductor, cuts the flux produced by this permanent magnet, that is the braking magnet, which is a permanent magnet. So it cuts the flux produced by this braking magnet. So what happened? And another EMF will be induced in the rotating disc, and because of that EMF, and another eddy current will flow in that conductor, which produces a torque. So that torque is called as braking torque. So this braking torque will opposes the motion of the disc, which is produced by the deflection torque. So this braking torque produced Tb will be directly proportional to the speed of the disc. Depending on the speed of the disc, this braking torque will be produced. Next one is the registering mechanism. How the amount of energy consumed is registered with the help of this registering mechanism. So we know a spindle is connected to recording mechanism through gears which record the energy supplied. So there will be a spindle in the center of the recording mechanism, which will be connected to the recording mechanism through gearing mechanism, which will record the amount of energy supplied based on the rotation of the disc. So for constant speed of rotation of the disc, the braking torque Tb must be equal to the deflection torque Td. So the braking torque Tb is proportional to the speed of the disc. So N, the deflection torque, is proportional to the amount of power consumed. So multiplying by T on both sides, we get Nt is equal to Nvi cos phi. We can say that Nt will be proportional to Nvi cos phi, which is proportional to P into, sorry, here P into T, where P is Vi cos phi. So Nt will be proportional to P into T. Therefore, number of revolutions in time T is proportional to the energy supplied in time T. So based on the number of revolutions for a period of time, the energy supplied can be measured with the help of this single phase energy meter. Let us see the advantages of single phase energy meter. Simple construction, cheap cost, it has more accuracy. Fourth one, less maintenance is needed. So most Because of these advantages, it is most commonly used for industrial and domestic applications in order to measure the amount of energy we have consumed. Next one is disadvantages. So, it can be used only for AC circuits. Since it works only on AC supply, it is used to power energy in case of AC circuits alone. Then creeping of energy meter causes error. So, what is creeping is the disc of the energy meter will rotate when there is no load current flowing through this current coil, when only the pressure coil is excited with the supply voltage. That is, it means we are not consuming any energy because there is no load current in the current coil, but even though we are not consuming any energy, the disc will rotate. What will does it? Because of the rotation of the disc, it will be recorded that we have consumed energy. So, this creeping causes error in case of a single phase energy meter due to over friction compensation. So, this has to be eliminated, and that is a disadvantage of single phase energy. So, in this class we have seen the single phase energy meter. The working is, we are having a shunt magnet M2 over which a pressure coil is wound, which will be connected across the supply voltage, and we are having a series magnet M1 on which the current coil will be wound, which will be connected to the load. In between the shunt and the series magnet, a aluminum disc will be placed. Around that aluminum disc there will be a C-shaped magnet called braking magnet in order to produce the braking torque. What happens when the supply voltage is given to the pressure coil? It will carry a current proportional to the supply voltage, and the current coil will carry the current proportional to the load current. So, the current flowing through the current coil will be proportional to the load current, and current through this pressure coil will be proportional to the supply voltage. And when the current flows through this pressure coil, what happens? The flux phi1 will be produced in this shunt magnet and flux produced in this series magnet. Part of the flux produced by the shunt magnet phi1 and phi2 links with this aluminum disc. Because of the flux, alternating fluxes phi1 and phi2, eddy currents I1, I2 will be induced in this aluminum disc. So, this aluminum disc will have small eddy currents, circulating currents in the produced in the aluminum disc because of the fluxes phi1 and phi2. Because of this eddy currents, torque will be produced, which makes the disc to rotate. Because of these two eddy currents, a rotating torque will be produced, which makes the disc to rotate. The disc starts rotating in the field of a permanent magnet. So, in the field of the permanent magnet, the disc will rotate. What happens? This disc acts as a conductor. It will cut the flux produced by this permanent magnet. So, because of this action, another EMF will be induced in this disc, which causes another eddy current to be induced. So, this eddy current produced by this fluxes will oppose the eddy current produced by this shunt and shunt magnet. So, the eddy current produced by this C-shaped magnet will oppose the cause producing is, which is nothing but the rotation of the disc due to this eddy currents. So, the disc speed can be controlled with the help of this C-shaped magnet, which is a permanent magnet. Now, the rotation of the disc will be connected to a spindle. So, this spindle will be connected to recording mechanism. So, the recording mechanism will be a gear of trains which will be attached to a pinion with the help of a pinion arrangement. So, it will record the number of revolutions of the disc. So, the number of revolutions of the disc will be directly proportional to the power or energy consumed over a period of time. Here let us see the single phase energy meter. So, this single phase energy meter, as we have seen in the diagram, has two coils. This one is the current coil, which is made up of heavy gauge wire, and this one is the pressure coil, which is mounted on the shunt magnet. It is made up of very few turns of very thin wires. It carries a current proportional to the supply voltage. It will be connected across supply voltage, and this current coil will be connected across the load. And this is the disc arrangement. So the disc will be placed between the current coil and the pressure coil. So the disc will be connected with the help of a spindle through a registering mechanism. So this registering mechanism will record the number of revolutions made by the disc, because when the disc rotates, the spindle through which recording mechanism has been attached also will rotate. So the current coil will carry the load current and the pressure coil will carry the supply voltage. And we have a C-shaped magnet. Here it is a C-shaped braking magnet which is used for producing the braking torque. So when this supply voltage is given to the pressure coil, the flux will be produced in this pressure coil, and the current coil will be connected to the load, also produces flux. These two fluxes link with this aluminum disc. Due to interaction of the fluxes, the aluminum disc starts rotating. So because of the rotation of the aluminum disc between this field of this permanent magnet, this braking magnet, this aluminum disc cuts the flux produced by this braking magnet. It also induces an EMF in the disc, which produces another eddy current. This eddy current will oppose the motion of the disc. So the speed of rotation of the disc can be controlled. So the amount of energy we have consumed for a period of time will be recorded with the help of this recording mechanism. So from the units consumed, we can calculate the amount of energy we have consumed. So in this class we have seen the construction working of single phase energy meter, which is used to measure the amount of electricity consumed over a period of time. Thank you.